Hello and welcome back to NorCal 715. If anybody recognizes this, this is a ABB flow meter computer, and they also go by Bailey Fischer Porter. This one actually has ABB Fischer Porter on it. It's kind of hard to make out the model number here, but it is an 1101. VM1101 is the model number. And I've got several of these in various states of disrepair, from the displays that aren't working too terribly good to some of the keypads don't work very well. You can see the ones with the X's on them, the keypads are not working. Now these devices are over 20 years old now, and so it is becoming harder and harder to find replacement parts. They are Y2K compatible, so that does give me a good feeling. So here's one of the swirl meters that they use, and it's a Bailey Fischer Porter, I'm sorry. And so I've got it set up here to the squirrel cage fan that's powered with a motor here. And then I have a little test bench set up over here where I can just plug the guts into it. And it's just plugged into a standard NEMA 515 plug, which I can plug right in the wall. So I'll take it and plug it in, and we'll see what happens over here. Hard to see with the ambient lighting, but it comes up and it gives me this message of EEPROM Failure 5, and that's one of the side effects to this. And the display is very dim as well. So as I try to change to the different modes, it says program shuts ein, and so it's in a different language, and it's kind of hard to navigate when you're not familiar with this language. But I'm going to show you a way to take care of that, because this is a version 52 EEPROM in this model, and I'm going to show you how to repair the display so it looks better, repair the keypad, and upgrade the EEPROM to a version 53. Okay, so now that I've got it on the bench here, the easiest thing to do, this has two EEPROMs in it. It has an EEPROM on the main unit, and then kind of hard to see right down in here, there is another EEPROM right there. So just to avoid any confusion, this chip right here is an EEPROM, EEPROM, electronically programmable read-only memory. That one right there, 24C 44PI, is a EEPROM, electronically erasable programmable read-only memory. And when I was saying that when I first plugged this in and it said the EEPROMs don't match, I was referring to that EEPROM versus this EEPROM. Now obviously if they don't match, you cannot reprogram this one. It's a one-time programmable memory. So the easiest thing I'm going to do is I'm going to take and hit 0, and that's going to be load data from external EEPROM, lade daten aus external EEPROM, and then I'm just going to press enter over here. And it's going to ask me if I'm sure. Yes, I am sure. And now it changed it back to English. So if I hit the clear button, as you can see, I'm getting an airflow, and it's showing me a pressure and a temperature at the same time. And the reason it's showing me the pressure and the temperature is because down here in the pressure plus and pressure minus, I just have a resistor installed in there. It's a 2.7K resistor. And in the RTD input, I just have a resistor put in there as well, so I get a fixed temperature reading. However, it is quite touchy. I'll show you the temperature up here if you can actually read it here. If I put my finger on the resistor, just my ambient heat is causing the temperature to fluctuate over here. Okay, so we'll start with just going ahead and taking the display and the keypad off of this guy. It's just a matter of the 4 screws here. The display and the keypad just simply plug onto the CPU circuit, so there's really nothing to worry about. We're not going to use the same keypad or the same display anymore. Just a little tug upward, and it unplugs. It pulled the ribbon cable right out there, and the display is held in with this little bus connector that just slips into these little terminals right here. So just go ahead and remove these 4 screws that hold the display into place also, and you will want to retain those screws. So there is the old display right here, which we will not be reusing. So here's the new displays that we will be using. There's a part number. Now I picked these up from Newark Farnell, and so let's just go ahead and get one of them out of the package here. All right, now these are a white with black segments. The original one was a green with black segments. And as you can tell, as they sit side by side here, they're almost identical. The biggest difference is if you turn these up on the edge, you can see that one of them is quite a bit thinner than the other one is. Most notably, if we just set them side by side, one of them will actually slide under the other one. So that's a small problem. And so we need to take this and take it out and shave about 100 thousandths off of these 4 posts in the corners, as well as shave these 2 little dimples down right here. And we're going to take the keypad off completely. It's just held on there with double-sided tape. It's just a membrane, cheap little keypad that fails over time. And you think they'd use better products when they're talking about a several $1,000 piece of equipment. So here's the keypad I've come up with to replace it. And I've just put a piece of ribbon cable so I can plug it into this connector right here when I need to service the unit in the field. But that's kind of an inconvenience, because I've got to take this whole piece completely off and out of the way anytime I want to make an adjustment. If we change one of the swirl meters, we need to change the K factors into the unit based on the new swirl meter, and it becomes kind of a problem to reprogram that. So what I'm going to do is show you how to take a connector like this. We'll take this keypad off, and then where the slot is, where the old one went through, we'll actually mount another one of these connectors in there, hot glue it in place, and fabricate a short little piece of ribbon cable so that we can have this all completely assembled and ready to go with our new white display. And then when we need to program one of these, we can plug what I've called my air gas service keypad into its place. So here's the DigiKey part number for the keyboard that I found, 88BB2. 8s and the B's look a little too much alike. So this is a one that I haven't modified yet. This is how they come out of the package. They're not labeled in any way. And as you can see on the one that I modified, I just simply solder the leads to the terminals, and then put a piece of sticky tape, and then put a piece of regular tape over the top of it. Keyboards are made by Grayhill, and they're tactile switches, so they'll last a long time. And so I just took a Sharpie and I just wrote down what my numbers were on there, so I can plug it into my computer and do the work I need to do to it. Okay, so here's the connectors I've decided to use, and these came from Newark once again. They're made by TE Connectivity, and the manufacturer part number is 5-520315-9, I believe it is. And I'll just show you real quickly what they look like. They're circuit board mount connectors here, and you can just attach your ribbon cable to it. And I'm gonna, like I said, I'm gonna take this keypad, and we'll rip out this old keyboard here, and we'll mill a slot here with the bridge port, and we'll go ahead and put one of these in its place, and we'll go ahead and solder it in place and cut a little short piece of ribbon cable and prep that ribbon cable and attach it. So now I'm going to start by making a new terminal strip, and I'm going to use this piece of THHN, and it's just regular 10 gauge wire. So all I've done is I've stripped a bunch of it, and I've got the individual wire strands out of the center. And so I've got a little pair of cutters right here, and I'm just going to start by, I'm just going to lay this new display over the top of the old terminals, and I'm going to put one wire in the hole. I'm going to press it down in there because it is spring-loaded terminals, and I'm going to just cut off a short little piece of it. It needs to be about 3/8 of an inch long approximately, and I'm going to go to the last hole. I'm going to do the same thing, and then I'll just go ahead and fill in all the other ones. Okay, so I've got all these done right now, and so what I'm going to do, it's going to be kind of hard to show on camera, but I'll do my best, is I'm just going to lift them up to about that point right there. And we're going to add some solder to the first and the last one, and then it will support itself after that, and I'll go ahead and solder all the rest of them. So I'm going to start by just tinning the tops of the first and the last ones, as well as I'm going to try to do this without having it flow. Just a droplet on each pad. Next, I'm going to very carefully lift it up and we'll just make contact with the first and the last one. Now it's going to support itself, so I'll just go down the line and solder each terminal. One at a time. Now don't worry about the last two. Now in this application, those are for the LEDs that provide the backlight. So now as you notice, over here we've got the anode and the cathode pins that we're not using, and they factory have some jumpers installed that route these two pins over here to this side where the LEDs are, anode and cathode. It does go through one of these current limiting resistors, so you don't have to worry about overdriving the backlight LED. So I'm just going to come over here and unsolder 2 and 4. 4 doesn't want to cooperate very well, but I think it's going to be okay. And now I'm going to apply solder over here on 5 and 6. So what that has effectively done is it has moved the LED terminals from these two terminals right here over to the VSS and VDD terminals, so it will drive the LEDs off my 5 volts that drives the whole display unit. So now these terminals are a little bit too long for practical use, so we have to trim them back a little bit, and they're going to be approximately 3/8 of an inch. So all I do is I come through here and I just lop off until they're about 3/8 of an inch. Seem to be going at a slight angle. I'll come by and we'll give them a haircut and make them better. Okay, well now to get the keypad off, we just have to remove this hot glue that they put on there. And of course, don't worry about damaging that ribbon cable. We're not going to reuse it. And now just pick a corner and try to get up under it. And get the green at the same time. There we go. Once you get that, it's just a matter of pulling it. Pull the ribbon cable out of there. That little shield piece, and now we have a slot. And we're just going to take that slot and mill it to the size of that connector. Okay, so I'm not got the slot all milled out, and I've got the connector just kind of sitting in the slot right now. So I'm just going to take a dab of hot glue. And we'll put a dab in that corner. And we'll put a little dab in that corner. And we'll just let those set up. Alright, now that those are set up, we'll just go ahead and fill this whole little crevice in with hot glue. And we'll turn it around and we'll hit the other side. Sorry, had that off camera, but there you go. There's the gist of it. Connector is mounted in place now. Alright, so here is the ribbon cable. And we're just going to take about probably 1.5 inches of it. And I'm just going to cut it with the pair of scissors. And that's what we end up with right there. And next, we're just going to scrape the coating off. I have this little knife. And we're just going to scrape the coating off of all the leads. Alright, there's our ribbon cable ready to go now. So next I'm just going to take these leads and I'm just going to bend them all down flat. Make it easier to attach to the ribbon cable. And just like I did on the display, I'm just going to put a little dab of solder You got to be quick on that because it is mounted to rubber or plastic and it will begin to melt. So I've got it slipped up underneath there. Okay, got all those done. Now I'm just going to take the hot glue and I'm just going to go over the entire connector with hot glue. So now we can go ahead and just use a tissue and wipe the inside of the display off so it's nice and clean. And then we want to go ahead and remove the protective coating from the new display and lift up that ribbon cable. Get the display in place. All right, that part is done. Everything looks good. The connector's mounted in place. It'll plug right into where the old ribbon cable used to plug in on that display. Got my pins all ready to go. A new header per se. Now, kind of hard to show this part of it, but just make sure that your connector lines up here with the socket. And then the next thing to do is just to make sure that all your pins get lined up into the respective holes. Sometimes that's easier said than done because you really can't see what's going on back inside here at all. There we go. And just go ahead and replace those 4 screws. Okay, it's ready to rock and roll at this point. Okay, so I've got it all ready here. Go ahead and plug it in. Fire it up. Comes up with the EEPROM error. So I'm going to plug my service keyboard into it. Got it right here. I'm going to press the number 0. Load data from external EEPROM. Enter. Warning, all data is going to be erased basically. Yes. And it's all good. I do not have the fan running. We'll go ahead, turn the fan on. It's got about a 10 or 12 second damping before it starts reading flow. There it goes. And it looks good. It's nice and bright. You can see it in the dark now. Looks really good. Next we'll go ahead and tackle the version 52 to version 53 replacement. Okay, so what I've got here is my Mini Pro USB EEPROM programmer. It connects to your laptop or your desktop computer via USB. Has a little program that comes with it. I've got a bunch of blank AT27C512 EEPROMs, old style EEPROMs. They do not have the UV window. They are not UV erasable. You may only program them once. And they're only $1 and some change a piece, so I decided to go with that instead of trying to get a UV lamp to erase those. I've already got it selected over here for that EEPROM. So I've got some EEPROMs that I've saved in the past. I've got version 52, which is the old version, and I've got version 53, which is the updated version that allows it to come back into English. So I'm just going to select that, open it, say okay. Here's the ASCII file and the hexadecimal code. So I'll just click one of these. We can scroll through it. Every now and then, as you scroll through it here, you can come up with some actual words. There's some words here: RAM, EEPROM, VRAM, EEPROM. And then, of course, here's some German. A lot of stuff in this system is German. So I'm just going to go ahead and write this data into one of the blank EEPROMs. And so it's just a matter of, I've got the unit ready to go right here, plugging the EEPROM into the socket, making sure I can get it into the right pins, locking the 0 ZIF, zero insertion force socket. And so I'm just going to go over here to program chip, and it tells me to put it into the 40-pin socket. Click program button, program, and you can see the light is lit, so it is programming, and the bar graph is going across right here. Try to get it so you can kind of, well, there's really no good place to put it here. So the bar graph is proceeding. So it's going to do a program, and then it's going to do a read to verify that what it wrote into the chip matches with what's in the file. So it's good. That chip is now programmed to version 53. So I've got a Sharpie here. I'm just going to write 53 on the chip, so I know that's a currently programmed chip. All right, so with the power removed, just go ahead and unplug the old EEPROM. It's in a socket. Pay particular attention to the direction. Pin 1 faces down on this one, so you want the tab to face down. There's my new EEPROM I programmed a few minutes ago. Press it into place. Plug the unit in. Now it should come on in English. You should never get that weird German, I assume, printing on it. In fact, what I'm going to do is I'm just going to take this module out. I'm going to plug a different module in here that I have. It should come up with the weird EEPROM's unequal. I'm going to write that EEPROM into it, unplug it, put the other module back in, plug the power in, and if all's well, it will come up in English now. EEPROM's unequal. So now if you wanted to on this one, you could press the decimal point, and the decimal point will take the data out of this EEPROM and write it into this EEPROM that you can't see that's off screen over here. If you press the 0, it will load the data from the external EEPROM, so that's what I'm going to do. Enter, enter, loading the data, and it's all good to go. Now press clear, and we're showing flow at this point. So next we'll go ahead and tackle power supply repair. There are, I think, 6 capacitors in this unit, 6 big electrolytic capacitors that should get replaced if you're going to do a maintenance on this device. Okay, so we'll go ahead and just disassemble this unit, and it's just a matter of taking these 4 nuts off the corners. Nope. Hopefully the camera stays still. There's one ribbon cable right over here. So unplug it, and the board just lifts right off. There's only that one ribbon cable. And then we're going to go ahead and replace 1, 2, 3 large capacitors and 1, 2, 3 small capacitors. So I'm just going to start by adding some fresh solder to the capacitors so that they do unsolder a little bit easier. This is 20-plus-year-old solder at this point. And they bend the leads over, so I have to take and kind of straighten them up. There, it's loose. They do put a little bit of glue on the other side. Kind of see the glue down in there. Anyhow, we'll do that for the other 5 capacitors as well. Okay, so here's the original capacitors that came out of the unit. They're all United Chemicon, it looks like, with the exception of this one capacitor right here, 470 at 63, and it's a Matsushita Panasonic type capacitor. Now I've opted to go ahead and replace them with all Nichicon type capacitors. So I've got my brand new Nichicons all ready to go in their place. And these were all obtained from Newark as well. Okay, I have all the new capacitors placed in position. These two are the 470s at 63. These two down in here are 470s at 25. This one's a 3300 at 16, and this one is a 330 at 35 volts, I do believe. So I have them ready to go. The leads are bent over slightly. And so normally what I'll do is I'll come over here and I'll do one lead on each capacitor. I'm going to stand the other lead straight up so there's no stress on the capacitor at that point. And then the hard part, standing up the other leads while it's hot. That way there's no stress on the individual capacitor leads. Now we'll just go ahead and trim them all. Okay, I've got all the leads trimmed. So I thought just as a test, I'll go ahead and do some ESR test. This is a B&K Precision ESR tester, equivalent series resistance. And so it's the same thing. If I short the leads together, it should read 0. It does. Actually, it reads 0.1, which is the lowest it'll read. So this is a 470 microfarad. So we'll go across the scale on the bottom. If it's anything other than 0.1 ohms, then we assume the capacitor is bad. And it reads 0.2. It's a little bit high. This is the other 470 microfarad capacitor. It checks good, 0.1. Now this one is a 3300, so it should actually be 0.1. It shouldn't be any higher than that. It is, it checks good. This one is a 470 at 25, so it should be, once again, down in the 0.1 range. Oh, it reads 0.6 ohms. That's definitely a culprit for some problems. The other 470 microfarad capacitor, 1.2 ohms. That's definitely a problem. That would definitely mess up the monitoring and the process of this unit. This is the 330 microfarad capacitor. It reads 0.7, and so as you can see, a 220 would read either 0.1 or 0.2 ohms at the absolute maximum value. A 470 would be 0.1, so a 330, if it's higher than 0.2 ohms, I would just assume it's bad, plain and simple. And it's 0.7 ohms. That is definitely a problem. Alright, so I'll show you how to build the service keypad real quickly. Once again, the part number is 88BB2. That's 88B as in boy, B as in boy 2. And I got this one from DigiKey. They are available from other suppliers, notably Newark has them. Now here's the part number for the ribbon cable as well. Now the manufacturer part number is Paul Sam Robert 1635-09. And the DigiKey part number is Adam Frank 09-5-N Nancy D David. I believe 5 refers to the length of it. And it is a 9-pin contact ribbon cable. And so what I'm going to do is I'm just going to, I got some right here. I'm just going to cut off probably about a foot. Ought to be pretty good. And then we're going to go ahead and prep the ends just like we did with that little short jumper we made just a little bit ago to connect the new connector on the where the keypad used to be into the processor board on the unit. So just like before, I'm just going to scrape away the coating on about the last probably 3/16, eighth of an inch, maybe a hair more, maybe 5/16, quarter inch. I don't know. It's not that critical, the distances. So I'm just going to do that to all the leads. Okay, so I've got the ribbon cable all prepped up. Both ends are on the same side, just to not get them confused. And this is going to be version 2 of this keyboard, so I'm actually going to solder it just like that. We don't use the far right hand lead, we use the first 8 counting from the left. And so it's going to end up being able to hang straight down like that. Now the connector that goes into the CPU plugs in this orientation with the pins down. So I want the keypad to face forward and then the pins to face down. And I'm going to bring it off the top on this one. So on my first one I brought it down off the bottom like that, and so when you're programming with it, you have to loop it around in this orientation, so when you let go it falls and faces the wrong direction. Okay, so on this one I'm just going to start and put a very quick little drop of hot glue right across the top, and then hopefully I can quickly land this in position, and it'll begin curing, and it'll stay there just like that. Sorry, it was off camera. And then I'll go ahead and solder the leads to it. So I can shift it just a little bit. That should be good. And then we'll go ahead and solder up the leads. Okay, so I've got the service keypad hooked up right here, and we'll just go ahead and hit a couple things, toggle through. There you can see that it is version 53. And we'll just do a quick save the data to the external EEPROM. There we go. Showing a flow, everything's good. Here are some of the other displays and EEPROMs that I have changed in the past. Please remember, if you enjoyed the video, consider making a donation to the PayPal donate button on my YouTube homepage. Everybody have a great day. Thanks for watching. I appreciate all your views and your comments. I try to answer as many as I can. Remember, with your help, we can keep these things out of the recycle bin and out of the landfill. Everybody have a great day. Bye-bye.